Okay, so we now want to start this integration by parts. Let me motivate you why we are even interested in this. So if you remember, we said that, okay, if I have the sum of two functions, for example, f of x plus g of x, we learned that if I want to calculate the integral of the sum, I can calculate the integral of each one of them individually and then add them up. So in other words, yeah, this integral acts as a linear function, so as a linear operator. So integral of a sum is the integral of the first one plus the integral of the second one, and the same is true for if I subtract them. But the question is that, is there any formula for the integral of the product? Okay, so I just want to mention that I have seen some students write integral of f of x times g of x dx to be the integral of f of x dx multiplied by integral of gx dx. Okay, but it is important just right away to say that this formula is not correct. Okay, and then it means that is there any formula that I can write for the integral of the product? So you will see that the answer is partially yes. You will see why it's partially yes. So I start with the derivative of the product fx gx. We learned that this becomes the derivative of the first one multiplied by the second one plus the other way around, the first one multiplied by the derivative of the second one. Okay, and now if I integrate both sides, it becomes integral of fx times g of x totally prime d of x. On the right hand side, of course, I can write the integral of the whole expression, but I know that the integral of the sum can be split into two parts, so it can be integral of the first one plus integral of the second one. Okay, but now the answer to this one is clear, yes, because I am differentiating first, then I'm integrating, so you know that integral undoes whatever actually the derivative did up to a factor, a constant factor. But that constant factor, I'm not worried about that, because I can take that constant factor and absorb it into these remaining integrals. So this is, I would write it as fx times gx. I don't need to be worried about that constant because there are two integrals left. I can consider that that constant is absorbed in one of these integrals. And then it becomes integral of f prime x gx dx, and then I have plus integral of f of x g prime of x dx. Now let me move this to the other side. What I will have f of x g of x minus integral of f prime x g of x d of x equals to the integral of f of x g prime of x dx. And of course it is common to write it from the other side, so if you don't mind, let me reverse these two. So I would write the integral of fx g prime x dx is equal to f of x g of x minus integral of f prime x gx dx. Okay, so that is the best we can do until the functions f and g are not given explicitly. I cannot do better than that, yes? Okay, but let us try to interpret this. First of all, I just want to tell you I was not able to answer the question because my question was that, is there any particular formula that I can write for the integral of the product of f and g? This is not exactly what I meant because this is not the product of my two functions f and g. This is the product of one of my functions f with the derivative of the second function g prime. Okay, but at least this is an integral of a product. One of them is a normal function, the other one is with a prime. It's a derivative. So what is it? If you look in this problem, into this formula, you will see something interesting. You see that here the prime is on g, but on the right hand side there is no prime on g, there is a prime on f. So somehow it means that I can flip the prime sign from g to f, but there is two prices that I have to pay. First of all, This minus sign is the price that I have to pay. And the second thing is that I have to also consider this product. So this means that if I have an integral of this form, where the integrand is a product of two functions, but one normal function, the other one the derivative of a function, then what I can do, I can flip this prime from g and put it on the other one, but I have to make sure that I put an extra minus sign, and I have also this term, which is usually called the boundary term. Okay, so let me take this with me to the next page to see that this is also somehow helpful in solving and finding some integrals. Okay, but now let us see if there is something we can do here. Do you remember we were supposed to calculate the integral, find the formula for the integral of the product of two functions f of x and g of x. But the formula that I got is only useful if one of the functions has a prime on it. In other words, it's a derivative. But of course, in my case, I don't have that prime here. But I can always bring that prime, yes? What's the price to pay? So what's the price to pay? I would write it as capital G x prime. So what is capital G? Capital G is a primitive function for G. Yes? And by definition, primitive function means a function whose derivative is equal to the original function. So even though when I start I do not have any prime, but instead of g itself I can write the primitive function of g, which is usually denoted by the capital letter, and then prime. And then I have dx. Now this formula is comparable to the formula we got. Am I allowed to flip this prime here? Yes, but there is a price to pay. So what is the price? I can write it as f of x capital G of x. So instead of this little g, I have capital G now. And then minus integral of f prime of x. Instead of little g, I put capital G and then dx. Okay, so we got a formula. So that's exactly what I wanted. So we can just drop the middle one and write that this one is equal to this expression. So that is called the integration by part formula. So this integral of f of x, g of x, dx is equal to little f of x, but not multiplied by g of x itself, multiplied by capital G of x, which is a primitive function for g, minus integral of the derivative of f, not multiplied by g, but multiplied by capital G, x dx. This is what we call integration by parts formula. Okay, and I just want to mention something from the beginning. This is not a formula that calculates my integral directly. What it does, it actually reduces the integral that I am interested in calculation to another integral. So this equality is always true, but it is not always useful. Because this reduces my integral to a new integral. This becomes also useful if this second integral is simpler than the original integral. So let me repeat, this formula is always true but not always useful. It is only useful if this new integral is simpler than the integral that I want to calculate. So to make it clear, let me give you an example. So let us say that I want to calculate integral of sine x times sine x dx. Again, if I ask you, do you know a primitive function for this? The answer is x squared over 2. Do you know a primitive function for this one? The answer is minus cosine x. But don't make that mistake and multiply them. Even though this is a product, but this is not true that the integral of a product is the product of integrals. So don't write this answer. But now, because you have a product, and apparently if you have learned what I said in the previous lecture, you realize that none of the methods we learned before is useful for here. So this is why you start thinking about might be that the integration by parts formula, which says something about the integral of a product, is useful here. But that is up to you. You see, this formula is completely symmetric because it doesn't matter. You can interchange the role of f and g. For example, if you switch these two in your head, then what happens? This becomes capital F, this becomes little g, and then here when you write it here, this becomes g prime, and then this becomes capital F. So it doesn't matter because it is interchangeable. The role of f and g are interchangeable. And it is important, by the way, because when I see this one, I really don't know if this is supposed to be little f and this is supposed to be little g, or the other way around. And then this is also important. It doesn't matter how do you interpret them. As far as the equality is concerned, both of the equalities will be true, but you will see one of them is useful, the other one is not useful. And sometimes we have to do some trial and error to see which one works. And of course, if you solve more problems, you will gain more experience in being able to do it properly. Okay, so let us just randomly to see if it works or not. Let me give the role of little f to this x, and let me give the role of little g to the sine x to little g. And then I want to write the formula. But in order to write my formula, I need to find this capital G. So what is capital G? Capital G is a primitive function of little g. So let me write it here. We decided to have g of x to be sine x. So this means that I am looking for a primitive function so that I can call it capital G. It is minus cosine x. You can add any constant, but a primitive function is enough. So now everything is ready and I can put it in my formula. So let us do that. Okay, f, which is x, multiplied by capital G, which is minus cosine x. So this becomes equal to x times minus cosine x. And then I have a minus sign integral, so I would write minus integral. But now I need f prime x. F is x, so f prime is nothing except 1 multiplied by capital G, which is minus cosine x dx. Okay, so let me write it. This one becomes minus x cosine x. And this minus sign times 1 is minus 1 times this one becomes plus integral of cosine x dx. Okay, so is it useful now? Definitely yes. So I was able to reduce my given integral to calculating this integral, but this integral is definitely simpler than this integral, as it is immediately doable because the answer according to what we saw is sine x. So this means that the answer will be minus x cosine x plus sine x. And now I, of course, add a constant c at the end. Yes? So we were able to do that. Okay, this was done. But I just want to tell you that let us see what happens if I interchange the role of f and g, because when you see this one, x times sine x, you don't know which one is f, which one is g. So let's do it the other way around. So if I want to write this, okay, let me this time to take this one to be g and this one to be f and put them in the formula. Okay, but this time my capital G will change. Yes, so capital G will be a primitive function of little g. A primitive function for x is 1/2 x squared. Okay, so let us now continue. So this becomes equal to, according to the formula, little f times capital G. Little f is sine x, capital G is this expression. So this becomes 1/2 x squared sine x minus integral of f prime x. F prime x becomes cosine, multiplied by capital G, which is 1/2 x squared dx. Okay, So let me just organize it a little bit. I copy and paste the first term. I pull this 1/2 out, so it becomes minus a half integral x squared cosine x dx. Okay, so I got a correct equality. Definitely this integral is also equal to this expression. But the problem is that this formula in this order is not helping me at all, because it's changed my integral to a new integral. But this integral, I hope you agree with me, it is even harder than my original integral. So sine and cosine are comparable, but instead of having x in my original integral, I have second power of x. So even though this equality is right, but it is useless because I am making life harder for myself. So that's extremely important to see that it is important to see which one it is better to take f and which one to take g. Okay, so this is one way of dealing with the formula of integration by parts, but I also prefer do it in this way, another way. So for example, we can write it like this. So this is common that people call this one dg, for example, and then this one together df, and then the left hand side becomes integral of f dg, then it becomes f times g minus integral of the other way around g df. So this is a very simple version of the integration by parts. But of course, instead of letters f and g, it is very common if you look at calculus books, instead of f we have u, and instead of g we have v, as I have written it in the lecture notes. Okay? Okay, but this I will continue later. So next time I will solve more problems and more exercises, and that we use integration by parts. But that is up to you. I will also teach you how to use this. Then you can choose which one is preferable for you and more comfortable. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.